Okay, so in this video, we're looking at factorising quadratics with three terms. So we've already looked at the two terms in the other video. We're going to look at three terms now. Now this is, I guess, probably the most common one you'll see. It doesn't really matter which one it is, but this is more common than the four terms and probably a bit more common than the two terms. But it's anything of the form ax squared plus bx plus c. So it's when you have an x squared term, an x term, and a constant term. So when you see the whole gamut of terms, you can have the monic or non-monic versions. Now, monic quadratics is when the coefficient of x squared here is just equal to 1. So you wouldn't even have an a there, it'd just be x squared. They're kind of the simplest to deal with. Or you have non-monic, when a can be anything except for 1 or 0. If it's 1, it becomes monic. If it's 0, it becomes linear. So you've got to be a little bit careful with that. But anything except for 0 or 1 makes it non-monic. Now, there are a bunch of different ways to factorise three terms, and I guess that's probably what makes it the hardest thing to do in quadratics. It's difficult because you have to select the correct one. Often if I tell students which method to use, it's okay, but it's trying to select the right one causes the most problems. Now, if you can do by inspection, that's useful for monic, mostly the monic quadratics. But some non-monics are easy to do this way as well. So usually monic, but some non-monic ones work too. The cross method I'll show you in a minute is kind of a little bit like the by inspection version, but a little bit more detail. Or you can use 2x2 grouping. This is when I would only use this for non-monics, so I wouldn't use this for monic ones. Monic ones, I'd go straight to by inspection or completing the square. This is for either case. This will always work, but it's not always the best one. If you are not sure, you can't think of how to solve or factorise by inspection, completing the square will work. It's just, I guess, it'd be like using a sledgehammer instead of a gentle hammer to do something. It might also take a lot more work than you need to. It is useful though, because it gives turning point form on the way through. So as you're completing the square, you can just see a turning point form appear, and then you can finish factorising, but you get your turning point for your quadratic. So that is useful from that point of view. But they're the three main methods we're going to look at, all four, I guess, we're going to look at. One key thing, always take out common factors, because something might be non-monic, because it might have a 2 in the front, but you might be able to remove that 2 as a factor and that drops out to being a monic. So always look for that. So let's do it. First one, we have a monic quadratic, x squared plus 12x plus 27. Remember, by inspection means we're going to look for factors of 27 that add to 12. Factors of 27 that add to 12. Now you can go through and list all your factors of 27. There's not many. It's going to be 27 times 1, or it's going to be 9 times 3 in this case. And clearly you can see which pair gives you 27 and 12. Once you know that, you can just chuck it straight into your equation here, and you're done. So always look for by inspection first, because it's really quick and really straightforward. Next one, we have a monic one again, so it's a 1x squared at the front. So monic, the first thing I want to check is, can I do it by inspection? So by inspection means I'm going to find factors of -30 that add to the -7. So let's try that. So factors equal -30 that add to -7. Well, no, factors of 30 are 5 times 6, and one of them has to be negative. So I did 5 times -6, 5 plus -6. Well, this one works, this one does not. So you know it can't be 5 and 6. So you'd have to think of different factors. Now you might have already come to them. I'm just showing that you can get factors that don't work. In this case, you can have 10 times 3 and 10 plus 3, but one of them has to be negative. To be a -7, then 10 must be negative. And once you have that, you know that -10 and +3 appear in your brackets. As simple as that. So by inspection, really straightforward. Next one, we now have a non-monic one. But remember we said always take out common factors first. So if I take the common factor out in this case, you're going to end up with 2 bracket x squared minus 8x plus 16. And then at this point, the 2 stays there. We might be able to go straight to the result by using inspection again. So let's check it. Can we think of any factors that of 16 that add to 8? Well, factors of 16 are 4 and 4, and 4 plus 4 is 8. So it's actually going to give me x, sorry, it should be negative, I should say, sorry, which means they both have to be negative, because negative times a negative gives you positive, and then these two add to negative 8. So you have x minus 4, bracket x minus 4, just like we have done in the previous examples, but it would make more sense instead of doing that to actually write 2 bracket x minus 4 squared. That's all by inspection. Let's see if we can continue that method, or we have to start looking at something a bit different. All right, we've got non-monic. A 2 again is at the front, which is nice, but notice this time it is not a common factor, so you cannot do common factors in this case. But you can actually try by inspection still, but this is kind of where the cross method idea comes out of it. So I talked about cross method before, and essentially what you can do is take these 2 brackets and you line them above each other like this. And then you imagine them, imagine you're doing your outsides, sorry, your first inside, your outside, your last, doing your whole expanding brackets. And think about how they're all connected. All right, so we know that the first term in the first bracket must multiply that one and must multiply that one. And the first term of the second bracket will multiply across, and the last terms will multiply each other. That's like our firsts, outsides, insides, lasts. That's your whole FOIL thing. So they're all multiplying together, which means this 21 has to be forming from these 2 multiplying. And the 2x squared has to be formed from these 2 multiplying. And the crossing bits together need to add up to negative 13. So let's think of factors of 2x squared. Well, you're going to have 2x and x. There's nothing else you can really do with 2 and 1 of the factors. And then it's a matter of finding the right places for the 7 and the 3. Sorry, 7 and 3 is 21. I wouldn't bother with 21 and 1 at this point because this number is not very big, but we might need to do it at some stage. But here I do 7 times 3. So it doesn't matter. I'm going to put a 7 there, 3 there, and see what happens. 2x times by 7 is 14. X times 3 is 3. So we've got 3x and x, but notice I also needed to account for negatives. A negative here, so it must be negative numbers. So let's do negative 7 and negative 3. And you're going to have negative 14 minus 3x, and that's going to give you negative 17x. That's not what we needed. That's no good to us. What that tells me is that the 3 and the 7 are wrong. But I can switch them around and change the order and see what happens. So let's switch the order and put the 7 at the top and the 3 down the bottom and see if that helps us. This time, 2x times negative 3 is negative 6x. X times negative 7 gives you negative 7x, and you get negative 13x. That matches the middle term here, which means it's 2x minus 7 is one bracket, and the x minus 3 is another bracket. Now you can simply do all of that just by looking at the original brackets. So you could do 2x there, x there, you could put a 7 there, 3 there, and put your minuses and check as you go, 2x squared and so forth. But essentially that's what you're doing with the cross method. Let's do it again, the next one. But maybe let's try it this time without writing it vertically. This is what we're doing. Now in this case, we've got a 4. The 4 is a little bit more annoying because 4 could be a 4 times 1 or it could be a 2 times 2. There's no real rule of thumb to follow. I guess I just look at the 11, the one in the middle, and see if I have 4s, a 4 times a 3 gets pretty close to the 12. So it is 12, which is close to 11. So I'm probably going to try 4x and an x first. If that doesn't work, I can just make them 2x and 2x. Doesn't matter. So your first terms, 4x times x, that's kind of like what we did over here. Second term, have to multiply to -3. So one's going to be positive, one's going to be negative. Which one's going to be positive? I'm going to try that one being positive, that one being negative. So now in our minds, we expand this out. So 4x times by 1 is 4x. -3 times x minus 3x. Whoop, that only gives me x. That tells me the 3 and the 1 are definitely in the wrong spots. If it was just the negative symbol and the positive symbol in the wrong spots, you would find you would have got -11x here, but it's actually in the wrong spot. So let's instead change the 1 and the 3 around. Put a 1 there and a 3 there and see what happens. 4x times x works. 4x times 3 is 12x. -1 times x. Those two together give you -11x, a positive 11x, sorry, and you get your result. That's the cross method. This last one, I could try the cross method, but I'm going to remind you of one last method, the 2x2 grouping one. This thing will work with cross method, but because of the 6, you can have 2 times 3 or 4 times or 6 times 1. It can get a little bit lengthy if you don't get the right combinations. Like the cross method is great if you get the right combinations quickly, or there's only one pair of factors for the first value. But when you have the more pairs of factors you have, particularly if this last one has more than one pair of factors, often this other method, the grouping method, becomes easier. So remember your grouping method. You would do 6 times -5, and that gives you -30. Once you have that, then you must think of 2 factors that give you -30 that add to give you that +7. Now in our case here, we know that 10 times 3 gives you 30. Let's put a negative on the 3. And 10 plus a -3 will give you the 7. That does not mean we can now write x plus 10, x minus 3 like a lot of students now do. We can't do that because, first of all, 10 times -3 is not -5, and x times x is not 6x squared. What we must do instead is we now split this middle term. So 6x squared, this 7x now becomes 10x minus 3x minus 5. Or I could have put minus 3x plus 10x, doesn't matter. At this point, we have 4 terms, and you pair each one up. So look for common factor in the first pair. Common factor is clearly x, and they're both even, so clearly it's 2. And we're left with 3x plus 5 in this first bracket. This second one is a negative in both, so we take the -1 out as a factor. You have 3x plus 5 gets written in here, and then we factorise, noticing we have the same bracket in both terms. So that means that must be a common factor coming out the front, and you're left with 2x minus 1. So that is the grouping way. And you could do the same thing with this one here. You could have done 4 times 3. -3 is -12. You could have had factors of -12 that add to 11, or you could do, to do that, you would have 12 times -1 and 12 plus -1, and you could have then written it as 4x squared plus 12x minus x minus 3. The first pair has a factor of 4x, and the second pair is a factor of -1. You get x plus 3 again, and notice x plus 3 comes out and the 4x minus 1 comes out. So the grouping method or 2x2, or the cross method, both work fine. These last examples, let's have a look at them. They're probably going to be completing the square, given all the other ones have been. Other ones, let's try it. So first of all, let's always check it's a monic. There's no common factors. Let's always check to see if you can find factors of 9 that add to 8. Or factors of 9 that add to 8. A lot of students mix these up and think, oh, yeah, I can get 8 and 1. But that's not the case because we're doing factors of 9. So 9 times 1, well, 9 plus 1 gives you 10. I can put a -1 there. 9 plus a -1 gives you 8, but that means I now get -9 there. we could try 3 times 3, but that only gives you 6 when you add them. So once you get to that point, you realize, no, I can't do it by inspection. I have to use completing the square. And remember, completing the square, the whole point is I want to get a perfect square there. So remember, we have x squared plus 8x plus something. We kick our 9 at the end. We're very exclusive with our 9. And we want to put some values in here, which are going to force a perfect square in here. And the way I do that is I remember the whole pattern of perfect squares. Perfect squares, when you expand them out, oh, you don't need a bracket there, whoops. You end up with the middle term is doubled of this one, and the last term is squared of this one. So going back into brackets, I would halve the 6 and square root the 9. So when I'm going back into the brackets here, I'm going to halve the 8 and get plus 4. So x plus 4 squared is the bracket I want. But then I have to remember that I kind of needed, I had a plus 9 I didn't have. If I expand this out, I'm going to get 4 squared, which will give me 16. But I had 9. So what I need to do instead is I now add 16, and this first half gives me that bracket, which is great. But if I just add 16, I now have plus 25. That was not the question. The original question had plus 9. I also need to subtract the 16. So everything before the yellow line is now factored into x plus 4 squared. Everything after the yellow line simplifies to become -7. And at this point, I've got one thing squared minus something else, which means I can use dots. So I square root each part. So square root of 7 is just root 7. And remember, dots, you have one thing squared minus another thing squared, ends up with a minus and a plus in each bracket. So you'll have a look at the video of factorising with 2 terms to see that one. Let's do this one here. So common factor of 2 in this case. Notice 2 goes in all of them, so 2 comes out. I'm going to have x squared minus 6x plus 7. Oops. Let's check for factors of 7. So multiply to 7 that add to -6. Well, factors of 7 now are 7 and 1. 7 times 1 is 7, great. 7 plus 1 does not work. I could do -7 plus 1, but then I have to have -7 times 1, but that does not give you +7. So no, you can't do this by inspection. You're going to have to do it with completing the square. So the 2 stays at the front. Remember, we're trying to get into a perfect square bracket down here. So x squared minus 6x. We're going to kick the 7 out to the end. Out there, that bracket stays on because that 2 is still multiplying that 7. Now in the bracket here, remember we halve that -6, so you get x minus 3 squared. And remember, we put a little line in the middle and break up the 2 halves. If I expanded this x minus 3 squared, you would actually have a plus 9 pop out there, which means I need to subtract 9 as well to make sure the equation is still balanced, because those two together give you 0. But I don't want to subtract them because it's not going to help me. So I've introduced the plus 9 so I can get this bracket, and the -9 at the end combines with the 7 and gives you -2. And you keep the bracket. And now last step, again, we've got one thing squared minus another. So we have x minus 3 minus root 2, x minus 3 plus root 2 using dots. Okay, last example. Now looking at this last example, you could use the cross method, or you could use 2 by 2 grouping, but let's try it with completing the square. But to do so with completing the square, you need to have a factor of 1 at the front. Okay, so we're going to have, whoops, it's 5 over 2x minus 3 over 2. So now we're going to complete the square on this thing. So we have x squared minus 5 over 2x. I'm going to kick out the minus 3 on 2 over here. And our next line down, remember we're trying to get a perfect square. So x minus, now half of 5 on 2 is what needs to go here like this. Squared, now half of 5 on 2 is not 5 on 2, it's 5 over 4. Now if I squared 5 over 4, to expand this bracket, you would get 25 over 16. So you're going to have plus 25 on 16 and minus 25 on 16. Fractions, we don't like fractions, but they're doable. And then we're going to simplify this last little bit here. So negative 3 over 2 over 16 is negative 24 over 16, multiplying top and bottom by 8. So together, negative 25 minus 24 gives you negative 49 over 16. Once again, we have dots, or dots, depending how you want to call it. So the 2 stays at the front, like this. We're going to have x minus 5 on 4 minus the square root of 49 on 16. Should put brackets there. We don't really need that square bracket anymore. And x minus 5 on 4 plus the square root of 49 on 16. And this is where we have to remember how to use sets. I'll get rid of this first square bracket, which we don't need anymore. You only need to have it until you've got 2 brackets. 2 stays there. Now x minus 5 on 4 is nice. Square root of 49 over 16 is 7 over 4. So we get minus another 7 over 4. X minus 5 on 4 plus 7 over 4. And let's continue to the end. So x negative 5 on 4 minus 7 on 4, that gives you negative 12 on 4, which is minus 3. That's kind of nice. And the other one, you have x, you get negative 5 plus 7 all over 4. Negative 5 plus 7 is 2. That gives you a half. So you get plus a half. And that's fully factorized. But because we've got a 2 at the front and a half in there, why don't we multiply that 2 into this bracket? Only multiplies into one of them, you don't multiply into both, otherwise you multiply the whole thing by 4. So 2 times x and 2 times a half gives you 1. And that is how you factorize with 3 terms. A brief summary of probably what you learned across a couple of weeks in Year 10.